Midpoint rule, as you can see, the midpoint rule is more accurate than the trapezoidal rule. And the trapezoidal rule is a little more complicated and weird. Midpoint rule is more accurate. But the Simpson rule is hands down much more. So I'm going to use these formulas. I know my B, I know my A, I know my delta X. I just need to find my K on each of these. That is to say, differentiate this function. What function? Ln x differentiated once, differentiated twice, differentiated 3 times, differentiated 4 times, and find the maximum of that in the interval 1 to 2. In absolute value. So my f of x is what? Ln x. So I need the derivative of that. What is the derivative?
1 over x.
1 over x. What's the second derivative?
Negative 1 over x squared.
Negative 1 over x squared. What is the third derivative? What is the third derivative?
2x cubed. 2 over x.
Or 2, yeah, right.
2 over x cubed.
Yeah, 2 over x.
2 over x cubed. What is the fourth derivative?
Negative 6 over x. So 4.
And if I'm looking at the absolute value, then I just need to look at 1 over x squared. And I need to look at 6 over x squared. Now, I really don't need a fancy calculus to find the maximum of what interval am I looking at? 1 to 2. So, I need to look at this function 1 over x squared between 1 and 2, and let's see what is its maximum. A key. So the maximum of the second derivative over the interval 1 to 2 is at x equal to 1. So I know that the second derivative in absolute value is no more than 1. Absolute value of the second derivative is 1 over x squared. And it's going down. So the maximum is at x equal to 1. If I was to say that, the maximum over the interval 1 to 2 of the absolute value of the second derivative is 1 over x squared. So my k is 1. On this particular example. So I will now calculate my errors for the midpoint in the trapezoidal rule. We'll use these formulas here. Let us find the error for the midpoint rule is less than or equal to k b minus a delta x squared over 24. That is to say my error is no more than 1 quarter squared over 24.
It's pretty small.
Quite small. Quite small. Anybody work that out? 84. I'm sorry?
1 over 192.
Okay, which is approximately what?
0.005.
0.00,
Yeah. 5, 2, 0.
which is to say that the exact answer is between that plus that and that minus that. Yeah. So the exact answer, which is quite phenomenal. The exact answer two numbers. My estimate plus the error and my estimate minus the error. Even though I don't know what it is. So say 0.388 plus 0.001 of the or between 0.388 minus. And I do not know the exact answer. For the trapezoidal rule, I'm going to do the same thing. I'm going to do the same calculation. I said I'm going to put what here? 12. That's what happened. And okay. Six. How about 1 and 2? 86. That's accurate, huh? You have a wider interval. So you don't know, you have less precision. You want your interval to be narrow. If you say the exact answer is here, or if you say the exact answer is here, more accurate. Much smaller than the interval. So you want this number to be very, very small. Now we'll see the Simpson's rule. Simpson's rule is the infinite. So I need now the fourth derivative. So I'm going to find the maximum of the fourth derivative in absolute value between 1 and 2. Simpson's rule. The error is less than or equal to. Delta x is still 1/4. This is still 1. Now I need a bound on the fourth derivative. The fourth derivative in absolute value is what? 6 over x to the power 4. The fourth derivative in absolute value. You want to know what is the maximum of that on the interval 1 to 2. And again, you know that this is a decreasing function. So the maximum is at x equals 1. Take your calculator and you will see it. 6 over x to the 4 also looks like that. No, its maximum is at x equals 1. Maximum of this over the interval is so I can put what here? 6. I know that the fourth derivative is no more than 6 in absolute value. It's changing quite fast in the fourth derivative, that is. 6. But I know that it's no more than that. This is 6, and this is 1 quarter to 4 over 180. Who can give me that in a fraction? Huh? Well, that's
It's,
6 over
256 times 180.
180 times, yeah, 256. What's 256 times 180? Oh, what's it divided? 60, 1 over 30 times, 2,560 times 3. 2,560 times 3.
That's 7,680.
What was it?
7680.
1 over 7680. My error is no more than that, which is quite a small number. Quite a small number. What is that in decimal?
That's 1.3 times 10 to the negative 4. So, yeah.
1, 2, yeah, 0.00013, and I just use 4 partitions. Just 4 partitions. That is to say, the exact answer. The exact answer is my approximation.